contradiction and its introduction. So here we are going to discuss about the introductory part of the contradiction and its proof. We are performing one illustration in order to prove a contradiction. So here the contradiction mean it is a compound statement which contains only f, that mean false truth values in the last column of the truth table, then only such a statements are said to be called as the contradictions. Then now here contradiction, the truth values in the last column of the truth table must be of false, then such a statements are said to be, such a compound statements are said to be called as the contradictions. So here compound statements containing only f. So here f indicates the truth value that is false in the last columns of the truth table are called contradictions. From this it is clear that whereas in case of a truth table of a statement, so here the last column must contain only the false statements, so false truth values, then only such a compound statements are said to be called as the contradictions. Then now let us illustrate by means of an example. So here the illustration starts now. So in our illustration we have to show or prove that the statement that is nothing but P and negation Q and, so within the second square brackets, so here negation P or Q. So we have to show this as the contradiction. Then now, so in order to show the statement that is P and negation Q and negation P or Q as a contradiction, so we have to assume two statements, that as one as P, the other as Q. Then now solution starts now. So in our solution, so here as per the statement or as per the condition that is given, so here the condition which is given to us is of P and negation Q within the first square brackets and negation P or Q. So here this is of the first statement and this is of the second statement. They are connected by means of a connective, that is and. Therefore this complete statement is said to be called as a compound statement. We have to prove this compound statement as a contradiction. In order to prove that this statement, that is the compound statement, as a contradiction, we have to show that the truth values in the last column as false. So each and every truth value in the last column must be of false. Then and only then, so here the statement that is the compound statement will be of a contradiction. Then now, so this is the truth table. So in our truth table, we are going to consider the two statements that as P and as well as Q. Then now, So first statement has P, the second statement has Q. Then now here, whereas as per the compound statement we need negation P and as well as negation Q in both the simple statements. That is, we need negation P and as well as negation Q also. Then now after getting the negation P and negation Q, then now let us find out the first one, the first simple statement, that is P and negation Q. So here P and negation Q. Then after getting the first simple statement, we have to find out the second simple statement, that is negation P or Q. So here negation P or Q. Then after getting the negation P or Q, we have to find out the compound statement, that is P and negation Q and negation P or Q. Then now here in this column, so here P and negation Q and negation P or Q. Then now let us indicate by means of the column numbers. So here this is of column number 1, 2, 3, this is the fourth column, fifth, and this is the sixth one, and this is the last column as the seventh column. Then now, so here we know that when we assume a single statement, that is P, then that statement may be either true or false but not both. Then only it is said to be called as a statement. So there are only two possibilities when we assume only a single statement. But here we have assumed two statements, that as one as P, other as Q. Then the possibilities will be of 4. In case if there are of 3 assumed statements, that is P, Q and as well as R, then the possibilities will be of 8. Then now here, whereas in our compound statement, there are only 2 statements, 2 simple statements, assumed statements are of one as P, the other as Q. Then the possibilities will be of 4, they are of in this manner. So here, if the truth value of the first statement, that is P, is of true, then the second statement Q also may be of true. So this is of one possibility, both may be true. So here if the truth value of the first statement P is of false, then the truth value of the second statement may also will be of false. So in this manner we can assume as the second possibility. Then now if the first statement is of true, then the second statement may be of false. If the first statement P is of false, then the second statement may be of true. So in this manner there are 4 possibilities, TT, FF, TF and FT. Then now we have to find out the negation of P in the third column, because as we need in the compound statement. Then now here statement P is of true, the truth value of in the first row, the truth value of the first statement is of true, then but we have to find out the negation of P. Negation indicates not P. Then if it is of true, then it is of negation P. P will be of not true. If it is of not true, then automatically it must be of false. Then now in the second case, if P is of true, then the negation P will be of not true. If it is of not true, it must be of false. Then now P is of false, then the negation P will be of not false, then automatically it must be of true. Then now P is of false, then now negation P will be of. So here false, then now not false mean it must be of true. Then now in the similar manner let us find out the negation of Q. So here if Q is of true, then the negation of Q, then the negation of Q will be of not true, then it must be of false. Then now if Q is of false, then the negation will be of true. Then now if it is of true, if Q is of true, then the negation will be of false. Then now in the last row, the statement Q is of false, then the negation of that Q will be of true. Then now Q, truth values are of TF, TF, and the negation Q, truth values are of FT and FT. Then now here we have to find out P and negation Q. So here the connective is of, and therefore it will come under the conjunction. So here in case of conjunction, in case the condition is of, if the first statement P is of true and the second statement negation Q is of true, then now here conjunction will be, so here that implies true, true, the conjunction also will be of true. Then that means, so here if the first statement P is of true and the negation Q, second statement is of true, then the conjunction also will be of true, that is TT is T. So in order to see this, in order to find out this conjunction, P is of the column number 1 and negation Q is of the column number 4. We have to see column number 1 and column number 4. Then in the column number 1 it is of P and column number 4 it is of negation Q. It must be of T and T. So here T and T is not there. So in the second row T and T is there. If T and T is there, then the negation will be of and the conjunction will be of true. Then now here it is of not T and T. So here also it is of not T and T. Then the remaining will be of false. Then now here we have to find out negation P or Q. So here the connective is of or, it indicates a disjunction. In case of a disjunction, the condition is of. If the first statement is of false and the second statement is also of false, then now the disjunction will be of false. But here FF is F, the condition is FF is F, but here negation P is of third column and Q is of second column. We have to see in the reverse manner. First of all, we have to see negation P, that is the third column, then the second column, third and second. But here it must be of F and F. So here F and F is not there, F and F is here. So negation P is F and negation Q is also F. So F and F will be of F. Then now here T and T, but we need F and F. So here T and F, but we need F and F. So only the second row is of false and the remaining all will be of true. Then now here on the whole, we have to find out the truth values of the given statement, that is P and negation Q and negation P or Q. But here P and negation Q is of fourth column and negation P or Q is of this sixth column. So we have to see fifth and sixth columns. So here, but the connective is of and. So here if it is of and, it will come under the conjunction. In case of a conjunction, the first statement is of true and the second statement is also of true, then the conjunction also will be of true. So the conjunction of the two statements, that is the first and second statements, will be of true. So here we have to see P and negation Q is under the column number 5 and negation P or Q is under the column number 6. So here first statement must be of true and the second statement must be of true. So true and the conjunction also will be of true. So here it is of false and true, it is of not true and true. So we need only true and true. So here it is of true and it is of false. It is not possible. Here it is of false and it is of true. It is not possible. Here it is of false and it is of true. It is not possible. We need only T and T, then only we will get T. But no, say no case is possible here. So here we won't get true, but we will getting only false in each and every row or the column. So here in the last column, so we got the truth values of only false. So since the truth values of the last column are of false, therefore the given statement, that is the P and negation Q and negation P or Q, will come under the contradiction. So in the next logical step, since the truth values of the last column of the truth table are of F. So here F indicates the false. So here hence the given statement that is the given compound statement, which is P and negation Q and negation P or Q, is a contradiction.